welcome to Wacky Wednesday Science, and we've been learning all about forces, pushes and pulls and friction. And today we're going to learn about, our learning objective is, we are learning how a force is measured. Okay, think about it, your pushes and your pulls, how can we measure that? How do we know how strong it is? Yesterday we looked at when we put more force behind something, it goes faster. And when we put a little bit of force behind something, it goes a little bit slower. But how do we know how to measure that force? Well, how do we know how big a force is? To know how big a force is, a push or a pull, we use this. Now, unfortunately, we're not in school. If we were in school, we would be using these to practice with our pairs, with our friends. But I still need to tell you what it is. Now, this is a little machine that measures the force, okay? Now, this is called a force meter, a force meter. It also has two other names, okay? It's called a Newton meter or a spring scales, okay? And this is used to measure force. Now, this measures force. Here it has a 0 at the top, and down here it has a 20 on the bottom, okay? It measures force using newtons. Remember, we measure length using meters, centimeters, millimeters. We measure liquids and capacities with milliliters and liters. We measure weight with grams and kilograms. Well, we measure force with something called newtons. Now, why do we call them newtons? Well, we call them newtons after the famous inventor, Isaac Newton. He did a lot of work about forces and motions, so that's why we measure force in newtons, okay? So, we are going to see how we measure force. Come on over here to the table with Miss Faye. Here we have our forceometer. If you have it, you can see the 0 is at the top. There's grams on this side. We can also weigh things, but we have better machines to weigh things. So we just use this for the force, okay? And this is a force of 20. So what we have to do is, first I'm going to measure the force of my book. You grab it with the hook at the end. Now, unfortunately, we can't measure pushes, we can only measure pulls. And we pull the book and we see where the little red pulley goes to on the forceometer to see how much force we need to pull the book. Are you ready? Okay, we need about, that has about 2 newtons of force to pull my big book. Might be a little tricky to see. Okay, now I'm going to try with another book. How many newtons of force do I need to pull this book? Ready? It's at 0. Can you see? And wow, that needs almost 5 newtons, 4 and a little newtons of force to pull that book. Okay. Now, one book was almost 2 newtons, and when we put the 2 big books together, it was more newtons of force. Why do you think it needed more force to pull the 2 books? What do you think? Okay, let's try one more really quickly. Let's try pull my stapler. Are you ready? Turn it around. Oh, let me turn it around so we can see. And is that 0? Almost. And now pull. Wow. It's hardly any force at all, maybe 1 newton or 0.5, a half a newton to pull my stapler. Why do you think that's so? Why do we need less force to pull the stapler than to pull the 2 books? I'd like you to think about that and answer the questions. Bye-bye.